Now we are going to move to question number 5. The constant term in the expression of x squared plus a over x to the power of 4 to the power of 9 is given as negative 28 divided by 9. So what constant term means? For example, if we expand 1 plus x squared, simply we can write it down as 1 plus 2x plus x squared. We call this term as constant term without any letter, only number. So we need to find this number part from this expression. So as I told you, if they ask you to find the specific coefficient, you need to use the general term of binomial expansion. So let's rewrite it again, a plus b to the power of n. The general term of this binomial expansion is n and r, a to the power of n minus r, and b to the power of r. So by using this one as a, this one b, and this one n, let's rewrite the general term. So n, which is 9 here, and r can be any number, as I told you. And instead of x, write down x squared to the power of n minus r, and then b a over x to the power of 4, and then r. Instead of n, please write down 9. This question is a bit tricky because you need to figure out what value of r by using rows of indices multiple times, not just one time. So let's do it one by one with me. So 9 and r first. And then please remember that a, b to the power of m. You can write it as a to the power of m and b to the power of m. Since x squared 9 minus r, so x to the, the laws of indices in this case should be a to the power of m to the power of n should be a to the power of m n. So you need to multiply out these two numbers, which is 2 times 9 minus r times here. This one is a fraction form. So a over b to the power of m equals a to the power of m divided by b to the power of m. So in this case, a to the power of r divided by x to the power of 4r first. And then 9 and r, x to the power of, let's expand that, 18 minus 2r times a to the power of r. And then if x is in the denominator, by using the negative number, you can express it in an indices form, which is x to the power of negative 4r. Let's write down number first, 9 and r, and a to the power of r, and x to the power of 18 minus 2r times x to the power of negative 4r. Since it's multiplication, by using addition between powers, x to the power of 18 minus 2r plus negative 4r, therefore 9 and r, a to the power of r, and x to the power of 18 minus 6r is the final version of general term. So from here to reach at this point, it needs to use multiple steps, the laws of indices. So anyway, to find the constant term, it means that no letter part. So this part should be 0. So 18 minus 6r equals 0. 18 equals 6r, therefore r is value of 3. So let's rewrite this one. So 9 and 3, a to the power of 3. That is the only constant term because this one is x to the power of 0 becomes 0, which is 1. And it is given as negative 28 over 9. So by using your calculator, you can find the value of 9 combination 3. Since I don't have calculator with me right now, I am going to calculate it by myself. 84. So 84 times a cubed equals negative 28 divided by 9. Therefore, a cubed should be negative 28 divided by 9 times 1 over 84. Please use your calculator, and it's negative 1 over 27. Since a cube equals negative 1 over 27, a equals negative 1 over 27 to the power of 1 over 3, then you can find this value as negative 1 over 3 is the answer. Let's move to the question number 6. I know these questions are not easy, but by practicing many times, I want you to figure out how to use general term of binomial expansion. You will learn it, but it needs many practice. So let's move to question number 6. Find the first four terms. When they ask you find four terms, from here 1, and then normally it's ascending orders in the expansion of 1 minus x over 10 to the power of 7. So a plus b to the power of n equals n0, a to the power of n, b to the power of 0 plus n1, a to the power of n minus 1. Please observe it's ascending, it's descending. The power here is ascending. n2, a to the power of n minus 2 and b squared. n3, a to the power of n minus 3 and b cubed plus dot 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 in this way. So please write it down as 1 plus negative x over 10. And this one a, this one b, this one should be n. Okay, let's substitute every value to each letter. So instead of n, write down 7 and 0. 1 to the power of 7, b, which is negative x over 10 to the power of 0 plus 7, 1 to the power of 6, negative x over 10 to the power of 1 plus 7 and 2, 1 to the power of 5, negative x over 10 to the power of square, 7 and 3, 1 to the power of 4, negative x over 10 to the power of 3, 1, 2, 3, 4. Since they ask you to find four terms, what we need to do is just simplify this expression. Let's do it. Please use your calculator. So it's 1 and 1, and this one 1 as well, plus 7 and 1 is 7. 1 is just 1 and negative x over 10 plus 7 and 2. By using your calculator, you can find it as 21, and 1 and negative square becomes positive, and then x squared over 100. By using your calculator, you can find this value 3 factorial, 4 factorial, 1, 2, 3, 4, 5, 6, 7. Since 3 factorial is 6, so they cancel them. What is left is 35. This one is 1. Negative cube becomes negative, and x cube over 10 cube is 1,000. So 1 minus 7 over 10x plus 21 over 100x squared minus 35 over 1,000 times x to the power of 3. Please simplify this value. So the final answer should be 1 minus 7 over 10x plus 21 over 100x squared minus 7 over 200x cubed is the answer of this question. And B, by choosing an appropriate value of x, find an approximation for 0.99 to the power of 7. You need to use this one, right? So 1 minus x over 10 to the power of 7 equals 0.99 to the power of 7. So you need to choose value of x to make this one as 0.99, which means 1 minus 1 over 100, right? 1 minus x over 10. Then the value of x should be 1 over 10, 0.1. So substitute 0.1 here because normally this question B is a following question from by A, so that you need to use the answer from A. So substitute 0.1 here, 0.1 here, 0.1 here. And then it's going to be -1 minus 0.7 times 0.1, which is 0.07 plus 0.21 times 0.1 squared, 0.01 minus 35 over 1,000 times 0.001, which is 1 minus 0.07 plus 0.0, 1, 2, 3, 4, 0, 0 to 1 minus 0.035 times, so 0.000035. So please calculate this value by using your calculator, and this is an approximation for 0.99 to the power of 7. Let's move question number 7. A is given as 2 minus square root 2 using the binomial expansion, or otherwise express a to the power of 5 in the form of a m plus n square root 2. Okay, so 2 minus square root 2 to the power of 5. 2 plus negative square root 2 to the power of 5. Maybe let's use Pascal triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 5. Sorry, 10, 10, 5, 1. And as I told you, this line represents n, the power. Since the power given is 5, so that we need to use this line. So firstly, write down all those coefficients, 1, 5, 10, 10, 5, and 1. And then write down this one, 2 to the power of 5 and negative square root 2 to the power of 0. Remember, if you add up 2 powers, it should be 5. And then 2 to the power of 4 and negative square root 2, 1. This one, 2 cube, and then negative square root 2 square. This one, 2 square, negative square root 2 and cube. 2 negative square root 2 and power of 4. 2 to the power of 0 and negative square root 2 to the power of 5. Let's rewrite this one. This value is 1. So what it left is just 32 plus 5 times 16, which is 80. And then negative square root 2 plus 10 times 8 times what is negative square root square. So negative square is positive, square root 2 square is 2. So therefore 160 plus this term, 10 times 4 times negative cube becomes negative square root 2, and cube is 2 square root 2. Therefore, negative 80 square root 2. And the next term, 5 times 2 is 10. And you can use your calculator, don't worry. The negative square root 2 to the power of 4 is going to be 4. So it's 40. And then it's 1 and negative 4 square root 2. Therefore, 32 minus 80 square root 2 plus 160 negative 80 square root 2 plus 40 negative 4 square root 2. Therefore, 32, 162, and 40, which is 232, and negative 164 square root 2 is the answer of this question. Therefore, the value of m equals 232. The value of n equals negative 164 is the answer of this question. Question number 8. Again, find the constant coefficient, constant coefficient. So this question is very similar to the question of question 5. Again, in this question, we need to use general term of the binomial expansion. A plus b to the power of n. The general term of this binomial expansion is n and r, a to the power of n minus r and b to the power of r. So a, and this one is b, the chunk b, and this one n. So 4n r, x cubed to the power of n minus r, which is 4 minus r, and then negative 2x negative 1 to the power of r. By using laws of indices, we need to simplify this expression. We need to simplify this one, 4n r, and by using laws of indices, you need to multiply out these two power, 3 times 4 minus r, and then let's separate it, negative 2 to the power of r, and x to the power of negative 1 to the power of r. So 4n r, let's write down this number to the front, negative 2 to the power of r, and then x to the power of 3, 4 minus r times x to the power of negative r. You can combine these two terms as x to the power of 12 minus 3r and then plus negative r. Therefore, 4n r, negative 2 to the power of r, and x to the power of 12 minus 3r minus r, which is 12 minus 4r. Since they ask you to find the constant means no letter, so that this power should be 0. Therefore, the value of r should be 3. So 4 and 3, negative 2 to the power of 3 is the constant term of this expansion. 4 and 3, which is 4, and negative 2 cubed is negative 8. Therefore, the constant term is negative 32 is the answer of this question. To help you to practice to apply the formula and the Pascal triangle, I'm going to show you how to solve this question number 9 by using two methods. Again, two methods. Fully expand and simplify this expression. Firstly, a plus b n to the power of n. Some of you might feel forward to see again and again and again how to do this one, but until you are super confident that you can use this formula, I am going to show it to you. So please be patient. So n and 1, n and 0, a to the power of n and b to the power of 0 plus n and 1, a to the power of n minus 1 and b to the power of 1 plus n and 2, a to the power of n minus 2 and b squared plus dot 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 in this way. So let's observe the structure of this formula. 0, 1, 2, this is ascending, n and minus 1 and minus 2 descending order, 0, 1, 2, they are ascending order. And the given expression is x squared plus negative 2 over x to the power of 4. So please consider this one as a, this one b, this one n. So 4 and 0, x squared to the power of n, which is 4, and negative 2 over x to the power of 0 plus 4 and 1, x squared to the power of 3, negative 2 over x and 1, 4 and 2, and a and power of 2, and b power of 2 plus 4 and 3, a to the power of 1, and b to the power of 3, 4 and 4, a to the power of 0, and b to the power of 4. Okay, And then since this value is 1, 4, 6, 4, and 1. And then this one is going to be x to the power of 8. This value is 1, so that's x to the power of 8 plus 4 times x to the power of 6 times negative 2 over x plus 6 times x to the power of 4 times negative square becomes positive. 2 square is 4 and x square is x square here plus 4 times x square, and negative cube becomes negative, and 2 cube is 8, and x cubed plus this one is 1 as well, and negative power of 4 is positive. 2 to the power of 4 is 16 over x to the power of 4. X to the power of 8 plus. Let's calculate the number first. 4 times negative 2 becomes negative 8. And then x to the power of 6 and x in the denominator. So that x cubed divided by x, which is x to the power of 5 plus 6 times 4 becomes 24. X to the power of 4 in the numerator, x squared in the denominator. You can cancel 2 x's each, which left is just 2 x's in the numerator. That's x squared. And then 4 times negative 8 becomes negative 32 first, and 2 x's in the numerator, 3 x's in the denominator. If you cancel 2 x's from each side, what is left is just 1 x in the denominator. So it's going to be 1 over x plus 16 over x to the power of 4. Therefore, the simplified version is x to the power of 8 minus 8 x to the power of 5 plus 24x squared minus 32 over x plus 16 over x to the power of 4 is the answer of this question. And then I am going to show you how to solve this question by using Pascal triangle. Pascal triangle firstly 1 1 1 1 2 1 1 3 3 1 1 4 6 4 1 again 4 here and then the first number 4 here so that you can use this line. So x squared plus negative 2 over x to the power of 4. Firstly, please write down the coefficient first. 1 plus 4 plus 6 plus 4 plus 6. Then this part, descending order, x squared to the power of the first power should be 4. And this one, negative 2 over x to the power of 0. Remember, addition of these two power, it should become 4, this one. Then x squared to the power of 3, and then negative 2 over x, 1. X squared power of 2, negative 2 over x squared. X squared power of 1, negative 2 over x to the power of 3. And then x squared to the power of 0, and then negative 2 over x to the power of 4. Let's simplify this expression. Equals, this one is 1, so that x to the power of 8 plus 4 times x to the power of 6 times negative 2 over x. Then plus 6 times x to the power of 4. And then negative 2 square is 4 over x squared plus 4 times x squared, and negative 2 cube is negative 8 divided by x cubed plus this one is going to be 1. Negative 2 to the power of 4 is 16 over x to the power of 4. After you simplify this one, as you can see, this one is going to be same as this answer we found before. So depending your own convenience, you can use either the formula or the Pascal triangle. But in my opinion, when the power is relatively low until up to 6, I prefer to use Pascal triangle because we don't have to use calculator, right? Okay, I am going to cut from here and then move on to the next video from the question number 10.